Hello everyone. Today we are going to start with chemistry chapter 5 periodic table. So how many elements are known to mankind till date? The answer is 118. 118 elements are known to us by far till today. Now, uh, since the elements started getting discovered and there was a need to classify the elements according to their properties to study them in a better way. So the chapter start with this sentence that it is a human instinct to classify, that is to put things of one kind in one group and of another kind in another group. That is kind of segregation. So periodic table is nothing but a segregation of the elements discovered so far, and also the elements which are yet to be discovered will be put in this periodic table. Towards the end of 18th and the beginning of 19th century, more and more elements begin to get discovered and their individual properties and compounds had begun to be studied. Soon the need arose for classifying them so as to make their comparative study easier. So the story starts from the end of 18th century, where there were, you can say, significant amount of elements discovered and their classification was absolute necessity. So what is the reason for classification of elements? It helps in studying the elements in an organized manner. It helps in correlating the properties of elements, compare the properties of elements with the fundamental properties of all states of matter. It helps in defining the relationship of one element with another. So these were the basic needs or reasons for classification of elements. In beginning, attempts were made by chemists to classify elements on the basis of factors such as density, malleability, ductility, etc., physical properties, and also to consider whether they were metals or non-metals. So these were some initial attempts, or you can say initial factors on which the classification was based. The physical properties, the physical state, the physical nature of elements. But none of these early classifications proved satisfactory because the number of elements falling in a particular group or category were so large that it did not serve the purpose of generalization. So generalization on the basis of these physical properties was very difficult because there were some elements which were metals fell into the category of non-metals, like mercury, which was liquid at room temperature. Now generally all metals are solids at room temperature. Mercury is liquid, so mercury fell into the category of non-metals because non-metals are mostly liquids and gases. Some are solids, some are liquids, some are gases. But metals are usually solids. So mercury was an exception. So due to these exceptions, that generalization was not possible. Some of the characteristics being considered varied under different conditions. Varied means some characteristics appeared to be different under differing conditions. Certain elements showed metallic as well as non-metallic characteristic. As I just told you, about mercury, but that was just about its physical state. But there are some metalloids. Metalloids, they show metallic as well as non-metallic characteristics. So it's very difficult to classify them. Obviously, scientists were in search of characteristics of an element that would never change and that would be unique. So, only on the basis of some unique characteristics, atoms can be classified, elements can be classified. And that classification is much more long lasting. That classification is much more worthwhile. That classification is much more, it makes sense. You understand? Otherwise, on general properties, on physical properties, if you classify it doesn't make any sense. So there was a need, or there was a search going on for some unique characteristic of an element that would never change, that would be unique for every element. It was William Prout or Proust, I'm not sure about that, because there is a scientist known as Proust also. So let me just Google search for you. William Prout. Yeah, that is Prout. William Prout. He was an English chemist, physician, and natural theologian. So he is remembered today mainly for what is called Prout's hypothesis. So I'm going to read about Prout in the chapter, but let me also show you who was Proust. Joseph Proust was a French chemist. Joseph Proust. So that was a French chemist, and what they are talking about is William Prout. William Prout, who discovered that the atomic mass of an element never differs, and that it could therefore form a truly scientific basis for satisfactory scheme of classification. So it was William Prout who suggested that atomic mass should be the basis of classification. Although now we know that he was not necessarily correct, and there is far more fundamental, you can say, property of an element which is now used for classification, which is atomic number. But atomic number came to light. Atomic number was discovered only after the discovery of electrons, which happened in early 20th century. So that is a long time to go from now, from what we are studying right now. So what we are studying right now is like the birth of periodic table. At that time, atomic number was not known. Atomic number तुम सबको पता है. Atomic number क्या होता है? Atomic number is the number of protons or the number of electrons present in one atom of any element. But electron proton का कोई पता ही नहीं था. What was known was the atomic mass. तो atomic mass के basis पे हम लोग classify कर सकते हैं. And William Prout suggested that atomic mass is quite unique. So on the basis of atomic mass we can classify elements. So the first classification was done by Dobreiner. J.W. Dobreiner, a German chemist, observed that certain elements displayed similar properties and that they could be placed in groups of 3 elements each. These groups of 3 elements each were called triads. तो डोब्रेनर ने क्या किया? एलिमेंट्स को 3-3 के ग्रुप में डिवाइड कर दिया, और ये ग्रुप को क्या बोला उसने? ट्रायड. The 3 elements of a particular triad has similar chemical properties. तीनों की प्रॉपर्टी सिमिलर थी ट्रायड में. In fact, Dobreiner was the first scientist to show clear relationship between properties of an element and its atomic mass. और डॉबरेनर ने एक लॉ बनाया जो यहाँ पे लिखा हुआ है, प्लीज नोट इट डाउन, इसको लर्न करना है तुम्हें, डॉबरेनर्स ट्रायड्स लॉ. The atomic mass of the middle element of a triad was approximately equal to the arithmetic mean or average of the atomic masses of the other two elements of that triad. Atomic mass of the middle element of the triad was approximately equal to the arithmetic mean or average of the atomic mass of the other two elements in the triad. फॉर एग्जाम्पल 3 एलिमेंट ले लिए डॉबरेनर ने, कैल्शियम, स्ट्रॉन्टियम एंड बैरियम. इनमें क्या सिमिलैरिटी है? ये तीनों मेटल्स है. ईच हैज एन ऑक्साइड दैट इज अल्कलाइन इन नेचर, मतलब इन तीनों के ऑक्साइड अल्कलाइन या बेसिक है, और तीनों की वैलेंसी है 2. वैलेंसी तब पता नहीं थी, अब हमें पता है, सो वी हैव नोटेड दैट डाउन. अच्छा, इसमें एटॉमिक मास कैल्शियम का है 40, स्ट्रॉन्टियम का है 88 और बैरियम का है 137. इट इज नोटिस्ड that the middle element strontium has atomic mass approximately equal to the average, that is the mean value of the atomic masses of calcium and barium. मतलब कैल्शियम और बैरियम के एटॉमिक मासेस को ऐड करके डिवाइड बाय 2 करोगे तो तुम्हें अप्रॉक्सीमेटली क्या मिलेगा? 88.5, विच इज वेरी नियर टू द एटॉमिक मास ऑफ स्ट्रॉन्टियम, द मिडल वन. यही तो बोला है इसमें, atomic mass of the middle element of the triad was approximately equal to the arithmetic mean or average of the atomic masses of the other two elements of the triad. ठीक है, this is nearly the same as atomic mass of strontium. दूसरा एक एग्जाम्पल, क्लोरीन जिसका atomic mass 35.5 है, ब्रोमीन with atomic mass 80 and iodine with atomic mass 127. They also form a triad because they all are non-metals. They all react with water to form acids and they all have valency of 1 minus. The mean of atomic mass of chlorine and iodine was approximately coming to 81.25, which is very near to 80, that is bromine, which is approximately the same as atomic mass of bromine. अब डॉबरेनर ने तो ट्रायड बना दिए, लेकिन इसका मेथड बहुत ही जल्द फेल हो गया. Why डॉबरेनर्स मेथड failed? डॉबरेनर failed to arrange all then known elements in the form of triads. The law did not fully apply even within the same family. For example, taking halogens, the first 3 members of halogens are fluorine, chlorine and bromine. It is observed that the mean atomic mass of fluorine and bromine is 49.5 but not 35.5 as it should be according to डॉबरेनर. मतलब डॉबरेनर का जो ट्रायड वाला मेथड था वो सारे एलिमेंट्स पे एप्लीकेबल नहीं था, सिर्फ कुछ ही एलिमेंट्स, 3 एलिमेंट्स के ग्रुप पे ही एप्लीकेबल था. सो डॉबरेनर के मेथड को डिस्कार्ड करना पड़ा. इट वॉज नॉट अ सक्सेसफुल मेथड फॉर क्लासिफाइंग एलिमेंट्स. ठीक है, बट ये फर्स्ट अटेम्प्ट था. याद रखो, साइंस में कोई भी चीज फेलियर के तौर पे नहीं देखी जाती है. वी नेवर सी एनीथिंग एज अ फेलियर इन साइंस. It is always a ladder, a step in the ladder, or a stepping stone for the scientist to come after. जो बाद में आने वाले साइंटिस्ट है वो इससे सीखते हैं और वो इससे आगे बढ़ते हैं. तो साइंस में फेलियर कहीं नहीं होता है. There is nothing called as failure in science. ये बात समझो, और ये लाइफ में भी एप्लीकेबल है. तुम अगर सोचते हो कि लाइफ में ये पॉइंट आ गया बस अब ये फेलियर है, वहीं से एक्चुअली तुम्हें नया विजन मिलता है, नई डायरेक्शन मिलती है. सो नेवर थिंक दैट अ सर्टन पॉइंट इन लाइफ is to be considered as full stop, end. इसके आगे तो कुछ नहीं हो सकता. फेलियर. ऐसा नहीं होता है. अब देखो, डॉबरिनर के बाद और एक साइंटिस्ट आ गया, जॉन न्यूलैंड, who was a scientist and a lover of music, arranged elements in ascending order of atomic mass and found that every eighth element had properties similar to the properties of the first element, just as the eighth note of musical octave is the same as the first note. तुमने म्यूजिकल नोट्स तो सुने ही होंगे. जैसे इंडियन म्यूजिक में हम सबको पता है, आई एम नॉट वेरी मच familiar to Western music and do, re, mi, fa, so, la, ti. No, I'm not familiar. I'm familiar with sa, re, ga, ma, pa. So, in Indian music or in Western music, there are 7 fundamental notes. And the 8th note, starting from any note, the 8th note resembles the tone of the first note from where you begin. So 8th note is a higher version of the first note. जैसे सा रे गा. Please excuse my singing skills, they are pathetic. एक तो मेरा गला खराब है, मैं जस्ट वायरल से रिकवर होने की कोशिश कर रहा हूँ, और मेरा गला भी काफ़ी ख़राब है, और ऊपर से मैं म्यूज़िक में अच्छा नहीं हूँ, मैं गाना नहीं गा सकता. बट फिर भी तुम लोगों के लिए एक ट्राई तो बनता है. सा रे गा मा पा दा नी सा 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 सा. डू यू सी दैट? सो इट गोज ऑन एंड ऑन. सा रे गा मा पा दा नी सा रे गा मा, आई डोंट नो, वो नेक्स्ट ऑक्टेव में चला जाएगा. सो यू कैन ईजिली, you can I think note it on a piano or a keyboard. Let me just see if we can get a piano over here. Online piano, virtual piano, yes. But wait, I don't have a, you can say, speaker over here, so I'm not sure whether you'll be able to hear it or not. You will be, because मेरे पास speaker नहीं है, but system के sounds तो directly record हो जाते हैं. So as you can see over here, I don't know what is written over here, I don't want to go through it, but if I start from here, this is your sa, okay, sa. ये वाला जो सा है तुम्हारा, सा, सा, ये नेक्स्ट ऑक्टेव में, दिस सा, एंड दिस इज इन फर्स्ट ऑक्टेव. तो ये सा और ये सा सिमिलर है, और फिर ये कंटिन्यू होता है. सॉरी, आगे, हाँ, यहां से, ठीक है. सो इट इज लाइक दैट. Virtual piano. I don't know whether you were able to listen to it or not. I'm not able to listen anything. But what I know is this is sa, and then this is the sa. So after 1, 2, 3, 4, 5, 6, 7 and 8th note on the piano resembles the sound of the first note. अगर यहाँ से शुरू करें तो 1, 2, 3, 4, 5, 6, 8th, तो इसका 8th नोट यहाँ पे है और दोनों का साउंड रिजेंबल करता है. वैसे ही म्यूजिक में 8th, जैसे म्यूजिक में 8th नोट ऑफ अ म्यूजिकल ऑक्टेव इज द सेम एज द फर्स्ट नोट. बेस्ड ऑन दिस ऑब्जर्वेशन, न्यूलैंड, इसलिए उसको लवर ऑफ म्यूजिक भी बोला है, क्योंकि उसने म्यूजिक में ये प्रॉपर्टी जो देखी थी, उसने ये अप्लाई किया केमिस्ट्री में. सच अ क्यूरियस केस. Based on this observation, Newland gave his law of octaves for classification of elements. According to Newland's law of octaves, when elements are arranged by increasing atomic mass, the properties of every eighth element starting from any element are a repetition of the properties of the starting element. The properties of every eighth element starting from any element are repetition of the properties of the starting element. ठीक है, जैसे कि हीलियम 1 2 3 4 5 6 7 और एट्थ एलिमेंट कौन सा आता है? फ्लोरीन. तो हीलियम और फ्लोरीन की प्रॉपर्टी सिमिलर है, लिथियम और सोडियम की सिमिलर है, बेरिलियम और मैग्नीशियम की सिमिलर है, बोरॉन और एल्यूमिनियम की सिमिलर है, एंड सो ऑन. ऐसा न्यूलैंड्स ने बोला. अब ये करेक्ट था या इसमें कुछ फॉल्ट था मुझे नहीं पता है, देखते हैं. Newland divided the elements into horizontal rows of 7 elements, each as shown above. The noble, that is inert gases, were not known at that time. तो noble gases का यहाँ पे कोई जगह ही नहीं है. ठीक है, इसका फायदे या मेरिट्स या फिर एडवांटेजेस क्या थे न्यूलैंड्स क्लासिफिकेशन के? This system worked quite well for the lighter elements. For example, lithium, sodium, potassium were brought together. It relates all the properties of elements to their atomic masses. For the first time, it was shown that there is a distinct periodicity in the properties of elements. Newland was honored in 1887. The Royal Society presented the Davy Medal to Newland in 1887 for his work on classification of elements. But Newland's method was not accepted fully. It was discarded. Reasons for discarding the law of octaves. Why was Newland's method discarded? This classification did not work with heavier elements, that is those lying beyond calcium. As more and more elements were discovered, they could not be fitted into Newland's octaves. Newland adjusted two elements, cobalt and nickel, in the same slot. कोबाल्ट और निकल को एक ही स्लॉट में डाल दिया उसने. इसका रीज़न उसने नहीं बताया. और ये CE आई थिंक सेलेनियम है एंड लैंथेनम, इनको भी एक साथ रखा. एंड दीज वर प्लेस्ड इन द सेम एज कॉलम एज फ्लोरीन एंड क्लोरीन. तो कोबाल्ट और निकल तो मेटल है, फ्लोरीन क्लोरीन हैलोजेंस है, नॉन मेटल्स है, इनको साथ में कैसे रख दिया? इसका भी रीज़न वो नहीं बता पाया. एंड ब्रोमीन विच हैव वेरी डिफरेंट प्रॉपर्टीज देन दीज एलिमेंट्स. आयन विच रिजेंबल्स cobalt and nickel in properties has been placed far away from these elements. तो मतलब heavy elements, heavy metals के लिए Newland's laws, I'm sorry, heavy metals या heavy elements के लिए Newland's octave में कोई जगह नहीं थी, और उसने कुछ dissimilar properties वाले एलिमेंट्स को एक ही कॉलम में रखा था, और सिमिलर प्रॉपर्टीज़ वाले जैसे कोबाल्ट, निकल एंड आयन, इनकी प्रॉपर्टी सिमिलर है, ये एक ही कॉलम में होनी चाहिए, इनको अलग अलग कर दिया उसने. ठीक है, सो दैट्स व्हाई द लॉ ऑफ ऑक्टेव्स वाज डिस्कार्डेड. सो वन मोर फेल्ड अटेम्प्ट, बट येस, इट इज़ आई थिंक द बिगिनिंग ऑफ समथिंग न्यू. एंड द नेक्स्ट साइंटिस्ट टू कम is Mendeleev, Dmitry Ivanovich Mendeleev, a Russian chemist. In 1869, arranged all the 63 elements known at that time in increasing order of their atomic mass. जो सबसे पहले किसने बताया था? विलियम प्राउट ने बताया था. वैसे ही मेंडलीव ने अरेंज किए 63 एलिमेंट्स को in increasing order of their atomic mass, and elements with similar properties were put one after the other in the same vertical column or group with blank spaces where the expected periodicity of the properties was disrupted. That is, where the properties of an element did not tally with the properties of the element placed above it. He observed that elements with similar properties occurred at regular intervals. This he called as periodicity of properties of elements. Based on this, he pronounced a law that is called Mendeleev's periodic law. So, क्या है Mendeleev's periodic law? Physical and chemical properties of elements are periodic functions of their atomic masses. So, Mendeleev suggested that when the elements are arranged in the increasing order of their atomic masses, they, on regular interval of time, they repeat their properties. Their properties are reoccurring. Their properties will reoccur or resemble to the properties of elements at regular intervals of time. Regular intervals, not regular intervals of time, but regular intervals in the periodic table. तो ये पीरियोडिक टेबल उसने सबसे पहले बनाया. पीरियोडिक टेबल जो टर्म है ना, ये मेंडलीव से आई है. दिस टर्म पीरियोडिक टेबल, जो चैप्टर का नाम है पीरियोडिक टेबल, ये मेंडलीव ने दिया है. ठीक है. सो व्हाट इज पीरियोडिक टेबल? Periodic table is a chart of elements prepared in such a way that elements with similar properties occur in the same vertical column or group. It is called periodic because elements with similar properties occur at fixed intervals or periods, and it is called table because elements are arranged in a tabular form. ठीक है. So एक chart है ये elements का, prepared in such a way that elements with similar properties occur in the same vertical column or group. सेम वर्टिकल कॉलम में एलिमेंट्स विद सिमिलर प्रॉपर्टीज अकर करते हैं, एंड इट इज कॉल्ड पीरियोडिक बिकॉज एलिमेंट्स विद सिमिलर प्रॉपर्टीज अकर एट फिक्स्ड इंटरवल्स और पीरियड्स, एंड इट इज कॉल्ड अ टेबल बिकॉज एलिमेंट्स आर अरेंज्ड इन टैब्यूलर फॉर्म. Essential features of Mendeleev's periodic table. Mendeleev's periodic table contains vertical columns called groups and horizontal rows called periods. ठीक है. सो ये याद रखना, ये सारी चीज़ें तुम्हें मॉडर्न पीरियोडिक टेबल में भी दिखने वाली है. ऐसा नहीं है कि सिर्फ दिस इज ओनली इन मेंडलीव्स पीरियोडिक टेबल. दिस इज द सेम थिंग हैज बीन used in the modern periodic table as well. So please note it down that vertical columns of the periodic tables are called groups and horizontal rows, vertical columns are called groups and horizontal rows are called periods. There are 8 groups, that is group 1 to group 8, Roman numbers, Roman numerals. Each of these groups from 1 to 7 is divided into 2 subgroups A and B. Each vertical column group is divided into 2 subgroups A and B, only from group 1 to group 7. Group 8 has no subgroup. Inert gases were not known at that time. Okay. All elements of a subgroup or group 8 which has no subgroup have similar properties. So this groups you see over here 1, 2, 3 subdivided into 2 parts, they all have similar properties. All elements of a subgroup or a group have similar properties. So group 1A elements have similar properties, group 1B elements have similar properties. Similarly, 2A elements and 2B elements have similar properties, 3A, 3B. So elements belonging to the same subgroup have similar properties, or the elements belonging to group 8 have similar properties and show the same valency. Not only have they have similar properties, but they also show the same valency, which is equal to the group number for up to group 4, or group number subtracted from 8 for group 5 to 8. So valency is equal to the group number for up to group 4 and group number subtracted from 8 from group 5 to 8. In a period, elements gradually change from metallic to non-metallic character, or metallic character decreases as one moves from left to right across a horizontal row. So in a period, the metallic character decreases from left to right across a horizontal row. Mendeleev's periodic table was published in German journal in 1872. He used letter R to represent the element of that particular group. Hydride of any element of group 4 is written as RH4. For example, hydride of carbon is CH4. Oxide of any element of the same group is RO2 or CO2. So if you can see over here, yeah, you will see R and H. R means element of that particular group, O is oxygen, S is hydrogen. So he wrote the respective formula for oxide and hydride of an element occurring in that particular group. Merits means advantages of Mendeleev's table. Grouping of elements. He generalized the study of elements then known to a study of mere 8 groups. Gaps for undiscovered elements. See, the first merit is that he grouped the elements in 8 different groups. So you just had to study 8 groups, that's all. You did not have to study 63 elements. But remember that you had to study only 8 groups. So that was much more easier. Gaps for undiscovered elements. Now this was really very much, you can say, a work of a visionary. Only a visionary scientist can think of something like this. That is, he left gaps for undiscovered elements. In order to make sure that elements having similar properties fell in the same vertical column, Mendeleev left some gaps in his periodic table. These gaps were left for subsequent inclusion of elements not known at that time. Mendeleev correctly thought that such elements would be discovered later. So there were gaps here and there in this periodic table, which were for the elements to be discovered later with the properties resembling to the elements which are already there in the periodic table. Prediction of properties of undiscovered elements. Now he not only left gaps for undiscovered elements, but he also predicted the properties of undiscovered elements. He predicted that the properties of then unknown elements on the basis of the periodic properties of the elements lying adjacent to the vertical slots. He actually predicted the properties of some undiscovered elements in 1871. For example, he named these undiscovered elements as Eka aluminium, Eka silicon, and Eka boron. Eka aluminium means one place below aluminium in the group. Its atomic mass and chemical properties are quite similar to those of element gallium discovered in 1876. Properties of Eka silicon are the properties of germanium. And Eka boron is not listed over here, but it also was one of the undiscovered element which is not given over here. So you can see the properties which were given by Mendeleev of Eka aluminium and Eka silicon. These are the properties given by Mendeleev. And these are the actual properties of gallium, that is the undiscovered element then. So similar to the properties given by Mendeleev. And similarly, you can see the similarities between the properties of Eka silicon, which was predicted by Mendeleev, and germanium, which is the actual element which was discovered later. Incorrect atomic mass corrected. He was able to correct the values of atomic mass of elements like gold and platinum by placing these elements strictly on the basis of similarities in their properties. So these 4 are the merits or advantages of Mendeleev's periodic table. But there were some defects in Mendeleev's periodic table as well. First defect is anomalous pairs. The following pairs of elements did not follow Mendeleev's principle. So Mendeleev's principle was to arrange the elements in increasing order of their atomic masses. But argon with atomic mass 39.9 precedes, means it is kept before potassium with atomic mass 39.1. Actually, according to his own law, argon should be after potassium because argon has more atomic mass as compared with potassium. But he placed argon before potassium and he did not have any reason for it. Cobalt with atomic mass 58.9 precedes nickel with atomic mass 58.6. So the first defect in Mendeleev's periodic table was anomalous pairs of elements which did not follow his principle. Third is tellurium with atomic mass 127.6 precedes iodine with atomic mass 126.9. Second defect is position of isotopes. What are isotopes? Isotopes of an element are the atoms of the element having similar chemical properties but different atomic masses, having same atomic number but different mass number. So these are isotopes. Like chlorine has got two isotopes. Both the isotopes of chlorine have atomic numbers 30. Atomic number 17. But please excuse my yawning in between. As I told you, I was not well. I was having viral and I'm taking these medicines which are really makes you sleepy, you know. Anyways, so yeah, isotopes have same atomic numbers but different mass numbers. That time, at the time of Mendeleev, atomic number was not known. So same physical properties but different atomic masses was the definition of isotopes. For example, chlorine has two isotopes, both have same atomic number 17 but different masses 35 and 37. So according to Mendeleev's periodic law, isotopes of an element must be given separate spaces in the periodic table, but since they have different atomic masses, but they were not assigned separate places. Grouping of chemically dissimilar elements. Elements such as copper and silver bear no resemblance to alkali metals, lithium and sodium, etc. But they have been placed together in the first group. Copper and silver in the first group, very weird, because in the first group there are lithium, sodium, alkaline metals. Copper and silver are transition metals. So they are kept in the first group, which is really weird. Separation of chemically similar elements. Chemically similar elements such as gold and platinum have been placed separate in separate groups. Doesn't make sense. Electron arrangement. It does not explain electron arrangement of elements. Of course, electron was not known. So the table was not made according to the electron arrangement. Position of hydrogen. Hydrogen was not given a fixed position. It was considered in group 1A as well as in group 7A because it forms both a positive and negative ion. So these were the defects, you can say, in the Mendeleev's periodic table. And this is basically the history of chemistry, the history of periodic table which we have studied up to now. Okay, now we will be entering into the era of modern periodic table, starting with modern periodic law. So atomic number was the basis of modern periodic law. Atomic number. The magnitude of positive charge present in nucleus of an element was determined by Henry Moseley, an English physicist. In 1913, Moseley used anodes of different metals in a discharge tube and subjected them to attack by cathode rays. So this experiment you must have studied in a chapter called Atomic Structure. He found that when cathode rays struck the anodes of different metals, the wavelength of rays produced changed. The wavelength of these rays were found to decrease in regular manner on changing the metal of the anode in order of their position in the periodic table. By this, he concluded that the number of positive charge present in the nucleus of an atom is the most fundamental property of atom. The number of unit positive charge present in the nucleus of an atom of a particular element is called the atomic number of that element, which is more fundamental than atomic mass, because two atoms of different elements can have same atomic mass but can never have same atomic number. So number of unit positive charge or number of electrons present in any atom is always more fundamental. Some of the positive charge present in the nucleus is due to protons. Number of protons is equal to the atomic number of that element. Thus, Henry Moseley found that atomic number is a better fundamental property of elements compared to atomic mass. This led to modern periodic law. So modern periodic law states that physical and chemical properties of elements are periodic functions of their atomic numbers, not atomic masses. And if elements are arranged, this is very important, if elements are arranged in order of their increasing atomic number, those with similar properties are repeated after regular intervals. That is, periodicity in the periodic table occurs based on the atomic numbers, that is, number of protons. Explanation for anomalies in Mendeleev's classification of elements. Number one, position of isotopes. Since all the isotopes of an element have same number of protons, their atomic number is also same, and since all isotopes in an element have same atomic number, they can be put in the same position in the periodic table. So why Mendeleev put all the isotopes together? This is the reason behind it. Mendeleev was really intelligent, a person with real vision of the future, and he did the right thing by, you can say, overwriting his own law, that is, atoms are the periodicity in periodic table is the function of atomic mass, but actually it's a function of atomic numbers. Now we know, and now we know that Mendeleev was correct. His mistake was not just a mistake, it was a correct decision. And position of argon and potassium. Atomic number of argon is 18 and atomic number of potassium is 19. So argon is definitely before potassium. So according to modern periodic law, elements are arranged in the increasing order of their atomic number. So argon with its lower atomic number should come first, and then potassium with its higher atomic number. So these things were explained by modern periodic law, which was, you can say, a gift of Henry Moseley in 1913, English physicist. He told that physical and chemical properties of elements are periodic functions of their atomic numbers, and that was path breaking. So there is this exercise 5A which you should be able to do now. Next we are going to cover the part which is preceding, which is following this, which is based on modern periodic table. Okay, it's not coming over here somehow. Anyway, so in the next video I'm going to cover that part. Till then, I want you to finish exercise 5A. Okay, so I'll see you in the next video. Bye-bye.